my presentation is entitled Optimized Linear Regression to Compute the Weibull Parameters. I am Mohammed Lamine Moussaoui from University of Sciences and Technology, Weibull, Algeria. An efficient, as an abstract, an efficient novel formulation for the computation of the beta and eta Weibull parameters is introduced in this work. This procedure consists to numerically optimize the errors between the data values shown in Figure 1 and the corresponding regression function values using the least squares method to fit these data. A numerical example is presented to compare the obtained results and their efficiency in precision and computing time. Here we show in this figure the data, and these data values are plotted on the Weibull logarithmic paper, as it is cited in this reference one by a linear curve. And this straight line gives the value of eta, which is equal to 60 on the eta axis, and a parallel curve gives the value of beta equal 3. The curve is plotted from the origin 0. This is the graphic method. The Weibull method is by the probabilistic Weibull law, which is very suitable to fit arbitrary statistical data obtained in general from performed computations. For a random variable t, which is distributed with the Weibull law, we give the form of f of t function, where beta is the shape parameter, gamma the position parameter, and eta the scale parameter for this PDF probability density function. Here in the following figure, we show typical Weibull density functions, where we have several forms which can be obtained experimentally or numerically. We have the left shifted distribution, or right shifted distribution, or centered distribution. And in the literature and the bibliography, we can show several distributions to represent a signal spectrum. For a periodic signal spectrum, which is arbitrarily shaped, we have here PDF probability density functions in the right side, which gives the peaks of the periodic signal. You can have a periodic signal with a period t, and the scaled curves correspond to the signal, and we have here various values of n number of standard deviations which are scaled. from the variance and the variable x. Parametering on the Weibull logarithmic paper, we use here the linearization form given in reference to y equal beta dot x plus c, where these components are given here. The parameters beta and eta have always been obtained by the graphical method, as we have seen in figure 1 on the Weibull logarithmic paper. This method is tedious, and the obtained data can generate a nonlinear curve in some cases, which needs to be difficultly adjusted to get a linear curve. The optimized Weibull process in this analysis is given as follows. Based on the square total error minimization, where the optimization model is defined with the utility objective function u of epsilon and the variables of decision epsilon in the vector, in this vector, and epsilon is defined by the difference between the data values and the statistical data values and the linear regression approximation of these values, given with the constants r and functions phi I. The objective function becomes u of r, where r are the new generalized variables which has to be found, or which are searched. The transformation gives the following approximation, following system of equations to be solved. This system of equations is obtained from the gradient of the function, and one has to solve a dot r equal b, where a is a matrix and r is the vector of the constants, and which form the approximation, and b is second term vector. The Weibull probabilistic law parameters can then be efficiently computed with beta equal r2 and eta equal exponential minus r1 over beta. We have here a numerical example. The data cited in figure 1 are in the table 1, and the corresponding values are in table 2. And solving the linear system of equations gives the expression of the constants, which forms the linear function. We can give here a comparison between these two methods. In the present method, in this analysis, gives beta equal 2.977 and eta equal 59.902. The graphical method has given 3 and 60. We can show in this analysis that the computed parameters with this numerical process are closer to those obtained from the data values on the Weibull plot on the logarithmic paper. The comparison is this numerical method takes some seconds to compute the searched Weibull parameters, and the graphical method takes several hours when the data values are complicated. which need some transformations. The conclusion is we have in this analysis performed the development of an efficient numerical method to determine the Weibull parameters. And this analysis allowed to save more time with respect to the graphical representation, which needs a costly, meticulous representation. The minimized errors between the nonlinear regression model and this numerical process, and the existing data values allowed to obtain the optimal coefficients corresponding to the optimal errors. Thank you for your attention.